The word that the public is going to use to really say the same thing is virtualization. We're actually taking this technology and bringing it to the customer edge and letting them access the same type of functionality from their home.
Welcome to episode 207 of the Community Broadband Bits podcast from the Institute for Local Self-Reliance. I'm Lisa Gonzalez. We've had Bruce Patterson, Ammon, Idaho's IT director, on the show before to talk about the city's fiber network. This time he's joining Chris to discuss recent developments as the city gets down to the business of building out its fiber-to-the-home network. As well as implementing a unique funding approach, Ammon is using its open access infrastructure to give users more control than they would have with a typical connection. In this interview, Bruce provides more detail about the plan and how Ammon is moving forward one neighborhood at a time. Be sure to check out our new video, Ammon's Model, the Virtual End of Cable Monopolies, and to learn more about their journey to become a network of the future at muninetworks.org. We have a number of stories that cover their progress. Now here's Chris and Bruce Patterson, IT Director at Ammon, Idaho.
Welcome to another edition of the Community Broadband Bits podcast. I'm Chris Mitchell, and today I'm speaking again with Bruce Patterson, the Technology Director for the City of Ammon in Idaho. Welcome back to the show.
Well, thanks for having me, Chris.
Well, I'm really excited to talk to you again. We've just completed this long, less than a year odyssey, but longer than we thought it would be to make this video about your project. Can you just tell me how you describe to people what you're doing in Ammon?
That can be a bit of a challenge at times, but the simplest thing that I tell them is that our focus is on the infrastructure, meaning that we're really focused on the fiber and trying to give residents and businesses in Ammon their own fiber and a sense of ownership over that fiber so that they can do the things that they want to do with that piece of infrastructure.
Great. And then for people who aren't familiar, this is infrastructure that will actually be owned by the city of Ammon, but it's kind of the way you're implementing it that will give people a sense of ownership in terms of how they can use it, right?
That's right. You know, we often hear open access, and that's really condensed down from this expression, open access networks, which implies that people that are users within that system can access multiple networks. We've taken it a step further, and we actually allow the user to create their own networks, which means that a user can technically become a provider, and the infrastructure itself is open to them to do innovative things.
So you end up with multiple virtual networks on top of one physical network.
That's right. And to the end user, it appears to be that they have their own virtual fiber to do with as they would like.
Well, I'm excited to see what turns out as you turn more people on. How many people are signed up to date?
Boy, last solid count we had was 188 out of 476 homes. So our first project encompasses 476 homes. So we were at exactly 50%, but we've had a number sign up since then, and we're still in the process of collecting all of that data and trying to find out where our total is. If you were to ask me today where I think we're at, I think we're at 200 out of that 476 and climbing from there.
And you've already had several pilot kind of people that have been walking through the system for a while, as well as your network is connecting a lot of local businesses and the schools and that sort of thing, right?
That's right. And the same technologies are being used. What's a little bit different with these homes that are starting to come on today is that we're actually giving them a user portal that allows them to interact directly with the network infrastructure and do the things that we're describing here.
Right, and that's actually worth just mentioning, I think, is that as you move forward, service providers could get on that portal, but you also have service providers that have been offering service without using the portal.
That's right. So it's something of a business model transition, if you were, and I think that the city's interested in maintaining the ability for outside businesses and entities to come in and negotiate contracts. But what we want for our residents within the city and our businesses within the city is a true utility rate, meaning it's ubiquitous and the cost is very low to maintain and operate the infrastructure because everybody's paying into it and we should all get the benefit from it.
Great. And for people who might be a little bit confused, definitely recommend that you watch the video before you listen to this podcast, because I think we're definitely going to assume some basic background knowledge. the rollout is being accomplished with a local improvement district. When we had talked for the video, we weren't really sure what those costs would look like. Can you tell me, if I'm a person signing up, what kind of costs I'm likely to pay and how that's broken down?
Well, we had to make our best guess going in, and we felt like $3,000 was a reasonable target if we could get 50% sign-up rate, meaning that out of every 10 homes, 5 in the area would hook up. We think that's a doable number based on the backbone infrastructure we already have in place. So because we already have that investment, there's no need for the residents to pay for that. They're really just paying for an installation of a fiber from the edge of their neighborhood into the heart of their neighborhood to their home, some installation of some equipment, and we think that $3,000 is a good number. And as we're working through the process, everything we've done to date really supports that number. We expect to be able to validate it completely over the next couple of weeks.
We've had a few questions from people as we've written about this model. Can you just remind us exactly how the fees work? So there's a one-time fee to get the fiber on the side of my house, and that's, as you mentioned, it's on the order of $3,000 if you hit the sort of targets of what you're forecasting in terms of the number of people signing up. And that can be broken out over many years of payments. What's the second fee that I'd have to pay on an ongoing basis?
So the second fee is the maintenance and operation of the fiber system itself, and that's done by the city, and we'll do that through a utility rate, meaning you get a bill from the city for sewer, for water, for garbage pickup. Included in that, if you decide to join the utility, you will receive a bill for $16.50 a month. If you want a 1 gig connection, we do offer a 10 gig if a resident desires that.
So if I start paying that and then I stop paying it, what happens?
Basically, if you don't pay the utility service, then that affects our ability to operate and maintain that fiber. So we've got power that we have to supply. We do locates. We do all these things to maintain the system. So what happens is we won't maintain that fiber for you when we basically turn it off. It's still there at your home because you paid for it, but we're not getting paid for maintenance and operation. Sometimes that's actually done voluntarily, Chris. We allow residents to fill out a paper form and say, I'm leaving for a long trip. Maybe they're going to be out of town for 6 months or a year, and they simply want to not pay that utility bill. They can voluntarily have it turned off, and we won't bill them for the period of time they're gone. When they come back, we charge a $45 fee to turn that back on for them.
And I guess I'm curious, what happens then if I decide I don't want to opt into this local improvement district, but then 2 years later I change my mind and I say, hey, I do actually want a fiber?
Well, at that point, we take a look at what it's going to cost to connect that home, and because you've not taken advantage of the option of doing it at scale with others that help to defray the cost, it's likely going to be a little bit higher than what everybody else has paid to come into it. And we can't amortize it, meaning that the bond process is closed at that point. So we can't find a way to take that debt, attach it to the property, and spread it out over 20 years at a low interest rate. So what we would require is that you would end up having to write us a check for probably $3,300 or $3,500.
And if I understand correctly, you've actually given an assurance to the people who do sign in that people who connect afterward are not going to get a better deal. So there's no incentive to wait longer.
That's correct. That's the feeling of City Council and I think all of staff, and the residents themselves appear to agree that the initial investment is made by those that opt into the system, and there's a general feeling that nobody should be allowed to come in any cheaper, and we agree with that. And frankly, the economics would indicate that it's not ever going to be cheaper than it will be today.
So one of the things that you had mentioned previously, and we actually talked about in our last podcast, but I think it's so important, I wanted to touch on it again, is the Lifeline idea. So, I've paid my $3,000. I am paying my maintenance fees, and I had been paying an ISP to get a gigabit service and maybe some other ISPs for other kinds of services, but I've lost my job and I'm trying to cut expenses. Tell me about this Lifeline feature that the city is going to be offering on the network.
So the city will allow a resident that is not taking service from an internet service provider, a commercial internet service provider, to tap into some internet bandwidth that the city maintains. And we're calling that a Lifeline service. And basically the way that will work is the city can log into their user account on the city's portal, and rather than signing up with a commercial provider and paying a certain fee per month for that internet bandwidth, they can go to the city under Lifeline service, request for bandwidth, and it will be given to them in 45-minute increments, meaning they basically are allowed to have 25 megabit internet service for 45 minutes, at which time it will time out. They can, of course, go back in and request another batch of 45 minutes and another and another. We will put a monthly data cap on it. At this point, we're not certain exactly what that is, but our intention is that, as you say, people that for some reason are disconnected from an ISP, maybe it's economic, or maybe there's something wrong with the service that they're getting through their ISP temporarily, or other things happen, they have another outlet that they can get instantly to be able to connect in a time of crisis or in a time of need to meet those needs, let their kids still do their homework, let them still apply for jobs and so forth.
Yeah, it's kind of funny. When we started recording this interview, our Comcast service here at our office went out, and it sure would have been nice if I had a portal where I could have just gone and quickly hooked on a different ISP to get through it. Because you might have one ISP that has an outage that's unrelated to the local fiber, and you'd be able to route around that really quickly, kind of like the internet is envisioned to do. But I guess the last question that I want to pursue on this topic is the city's not going to be an ISP on the network other than this Lifeline service and perhaps some public safety services. But I just wanted to verify you're not actually going to be like selling internet service to customers.
No, this is intended to be a Lifeline service. And for those that are down in the weeds technically to understand, it's a temporary connection. They wouldn't even receive their own dedicated public IP address. It's really a temporary connection, but it'll meet all the needs that they would have to be able to do the things that they need to do for critical functions, day-to-day life, because we're all starting to see the internet as essential to our everyday life, whether it's banking or, as we mentioned, job applications, or our kids being able to get information to do their schoolwork. Those are important things that we want our residents to be able to do even when they might be a little bit strapped or going through a difficult time.
So I want to turn to this idea of software-defined networking, which is really what powers your active shooter application that we talk about in the video. It's what powers this customer portal. What is software-defined networking?
The word that the public is going to use to really say the same thing is virtualization. So it's the idea that you take a physical asset and you can split it up and use it multiple times virtually. And so that's something we've seen in the data center world for quite a period of time. It's made its way into networking. It's not widely adopted by carriers, metro carriers, but it is something that we are seeing being implemented. It's something that oftentimes is implemented by carriers to help them manage their own networks. In other words, they make these virtual connections to deliver services, and they can create one network for an internet service and another network for their phone service, and they can create another network for their TV service, as it were. We're actually taking this technology and bringing it to the customer edge and letting them access this same type of functionality from their home.
So what does that mean in terms of, if you were to compare yourself to another city that was building a fiber network and offering a gig, and whether they were doing open access or not, what are you doing differently? I mean, like what kind of, what's different inside of your network? They're just different technologies? I mean, you're using the same fiber, right?
It's the same fiber, and a lot of the equipment is the same. And as you look at the vendors and manufacturers that make fiber optic equipment, many of them support these types of technologies. They're just a little bit off in some of the ways they apply them, but the functionality is largely the same. And the idea is that in the traditional method of setting up a network, when you have multiple pieces of equipment and they span a pretty large geographic area, what happens is you have to go to each piece of equipment, whether you're sitting there physically or you remotely log into it, and you have to set up each connection individually. And you say, take this port, incoming port, and connect it to this outgoing port and create this virtual connection through it so that it looks like a single fiber from point A to point B. And that's how you get it to pass through all these pieces of equipment. This idea of software-defined networking takes the control and puts it in a central location and allows you to just dynamically say, give me a connection from here to here, and the system itself goes in and makes those changes dynamically without having to physically log into each piece of equipment, as it were.
And I think that's the view from the network operator. My understanding is that ISPs, find this really important because it allows them to do things they might not otherwise be able to do. In particular, if you look at a future of open access in which you define open access as the ability of multiple ISPs to connect and offer services concurrently, at the same time to home users. I've heard some that are real big proponents of software-defined networking say that it's not really possible to do that unless you're using software-defined networking.
Well, I think it hugely simplifies the task because, as you can imagine, to bring on a new provider, if you're doing all of these things manually, is an enormous task in labor. Whereas if you've already got software-defined networking or virtualization set up in your network, it's very, very easy to bring a new provider on. So I agree with you 100%, Chris. That's really the secret, is how you implement this software-defined networking or this virtualization. And that's a choice that each network operator has to make about how they want to do it. Again, I think where we're a little bit different than most anybody else in the country is we're actually using it for our own benefit internally, but we're also taking that same functionality and turning some of it over to the edge user. So from your home, you have some ability to say, this is my provider, and I want this service as well, and I want these things, so that you don't have to call us and ask us to provision it. You can provision it yourself.
What are the security implications of that? I mean, when you have multiple virtual networks on the same physical network, how can we be sure that one isn't spying on the other?
So there's basic security protocols and procedures that every operator really needs to implement. I will make this comment that I think that the things that we're doing are actually more secure than the traditional method. And to prove that, you could take your cable modem, if you're on a cable network, and go to your neighbor's house and plug it in, and you'll notice how it works no matter where you're at, as long as you're plugging into their system, because their system is not aware of where you're at geographically. Our system, on the other hand, if you were to take your edge device from your home, go to your neighbors and plug it in, our system would tell us that you'd moved it and it wouldn't connect you. So we do have some security things in place that are dynamic and a little bit different. And again, it's the software-defined technology that allows us to actually do some of these specific security procedures. So there's actually some pluses to the methods we're using, not negatives.
And when you say edge device, you mean like the ports, the actual where the fiber comes in, and that's the physical piece of hardware, not like a computer or something like that.
That's right. That's exactly correct. It's the piece of equipment that we bring our fiber into that converts it from an optical signal to an electronic signal like you will typically see, so that you can cross a normal copper network cable. So that device, then, if you were to take that and try and move it, we would be aware of it and it wouldn't work in another premise or another location. That is not true with your DOCSIS cable modems that you get from your cable providers. Now, the phone company, they're typically aware when you move your DSL modem because they register that with your address. So there's some nuances here, and I don't want to get into all the technical details. I'm simply pointing out that SDN really, I believe, implemented correctly, improves your security. It does not reduce it.
Well, I have to assume that, with all these whiz-bang features that are coming out, are you paying a premium on your network to implement SDN?
There used to be a significant cost difference to implement these types of technologies, but they've become pretty pervasive. And most of the standards and protocols are implemented in the core and the access equipment. So the equipment that's actually housed within the switch points in our network typically have this functionality. So you might pay a little bit more, but it's an incremental increase. It's not exponential. So you might pay, say, 10% more for that. There is some cost distinction for the device at the home, because as I mentioned to you, that's one of the ways we're different, is we give this functionality to the actual homeowner or property owner to be able to do these things. And for us to enable that functionality all the way to that edge at the premise, there is a slight cost increase for that piece of equipment at the home. Having said that, it's an interesting dynamic, because if I were sitting in a position where I were starting from scratch today as a network designer operator, I would look at it and I would say, it really costs me virtually nothing to put equipment through my core that enables this. So I'm going to do that. And that gives me the flexibility later, if I want to go down this path of doing software-defined networking, of being able to simply do it, because then it's just software. It's not hardware, which means I don't have to buy new equipment.
Right. Well, that's one of the questions I have about virtualization, because my understanding with virtualization was that it allows you to basically get away from the high-end hardware and start to run it on more like commodity hardware.
That's true. And we're seeing that point in the market space, at least when we buy our equipment, where we are now able to finally get to white box commodity hardware, and we get to choose our software or our operating systems and firmware that are running on these switches from different vendors. And as long as the standards match up, we can always go with the best price. And so you are exactly correct, Christopher. Over the last year, we've seen prices drop per port dramatically.
So when you net it all out, do you think that over the next 5 or 10 years, you'll be saving money from going with this approach rather than a traditional approach one might have used 5 years ago?
I think it's more future-proof. So the first comment I'll make is that our core and access equipment is substantially cheaper than what we would expect to pay from a traditional vendor. So we can get white box solutions, as you're describing. The piece at the home, because there's more power there and it does more than the traditional model, it costs a little bit more. So that equalizes out. Where I think we're going to save is that we think that this equipment will last us much longer. When you look at the equipment change-out cycles that so many of the carriers go through, we go from DOCSIS 1 to DOCSIS 2 to DOCSIS 3 in the cable networks. We've gone from DSL to DSL2 to VDSL within the traditional phone carriers networks. This is all virtual, meaning that we think the hardware will last a long period of time, and all of the upgrades we're going to see are going to happen within the software, which comes at a very small price. So that's where we think we're going to get major gains, is through time.
Great. And then one last question about a city that might think about doing this. I'm really curious, in terms of you expanding this to connect more homes and businesses across the city, given that you are focusing on the infrastructure and you have so much automation and virtualization, what kind of staffing considerations have you had to consider in terms of having enough personnel and the right personnel to be able to roll this out?
We're in our infancy here, so I can talk about where we're at today and where we think we'll be. We have yet to prove a lot of things, Christopher, as you know. We feel confident on our course, but in answer to your question about staffing, I think we've got a lot less staff than many operators do. We have very, very few outages, and the outages that we do have are typically related to something at the premise that the property owner has control over, or it could be something with the service. So the chain of help ticket support comes from the provider for us. What I mean is the property owner calls their provider first. That provider helps them with that first tier of support. We get called if the provider cannot assist the property owner. And typically that means the provider of the internet service cannot see that premise or edge device at the address, which means there's a link down, which would be our problem. And what we've found is we have very, very little time actually spent in support. With fiber optic, it's very stable. Our network's very stable. It just runs and operates. For example, last year, I can recall one outage we had, and it was due to a lightning strike at an address that took out a piece of equipment on the side of a metal building. And we changed that out and had them back up and running within 45 minutes. Other than that, I don't think we had a single outage last year.
Well, that actually raises a point that I was thinking about getting into. I wasn't sure, but just to touch on, in terms of ISPs, one of the challenges historically in open access networks, the way that they were built, without this virtualization and automation, ISPs would complain that they didn't really have visibility into the network and they weren't able to troubleshoot as well. Is that something that the way you're implementing the network gives ISPs greater ability to figure out what's wrong with the connection without having to call you?
The great thing about virtualization is we can do whatever they would like. So the device we put at the home allows us to create a virtual box a virtual switch or router, whatever that ISP would like, we can create virtually, which means that there's no need for the customer or the provider to have to buy another piece of equipment, send it to that address, have them install it. We don't have to do that. We can basically create a virtual box, turn it on, and the ISP can do anything they would like with that. So once they see that ability, they understand we can prove that we have a certain level of performance at the address. We can test and measure what the bandwidth is ourselves. What's been very interesting about this, Chris, is that as we give them that ability, that's of course a layer of complication, I'll call it, but it's a traditional way. Some of them have decided that this is crucial to their business model and they want that ability. Others have decided that they don't need that layer of complexity. All they really want to know is, can they see that edge point? They don't care about being able to do specific tests. They just want to know if it's up and if it's on. The way our system works, they can do that without having a virtual presence at the premise. So some of them have decided they want a VM and some have decided they don't. And I think that's an indication of the market forces that are going to drive them towards least cost with performance that is acceptable to them and the customer.
Excellent. Well, thank you once again, Bruce. I think you've given a tremendous amount of time to helping other people understand what you're doing and sharing your knowledge. So I greatly appreciate that.
Well, thank you, Chris. Appreciate your time as well.
That was Chris and IT Director Bruce Patterson from Ammon, Idaho. Don't miss our video on Ammon. You can see it at muninetworks.org and on ILSR's YouTube channel. Don't forget, the transcript for this and other Community Broadband Bits podcasts is at muninetworks.org/broadbandbits. Send us your ideas for the show. Email us at podcast@muninetworks.org. Follow Chris on Twitter. His handle is @CommunityNets. Follow muninetworks.org stories on Twitter too, where the handle is @muninetworks.org. Thank you so much to the group Forget the Whale for their song, I Know Where You've Been, licensed through Creative Commons. And thanks for listening to episode 207 of the Community Broadband Bits podcast.